Okay, so our first unit starts with a continuation of solving equations. So part of our review work involved solving equations, and we're just going to kind of continue that work and kind of dive a little deeper into ways that we solve multi-step equations. And so we're going to start with a little review, and we've already looked at equations like this. So these are called two-step equations. And so on our first example, we want to isolate our variable, right? So as we move further with solving equations, we want to keep in mind, like, our goal is always to get the variable isolated or by itself. And so to do that, we use our inverse operations, right? So if I look at this variable, I can see that 8 is being added to that variable and 3 is being multiplied by that variable. And if you remember from our review work, we always want to start with any addition subtraction moves first. And then we would want to deal with any multiplication or division that's happening to our variable. And then I'm only talking about two-step equations. In a minute, it's going to get a little more complicated than that. But on example 1, first thing we would do is we'd say, well, the opposite of 8 is -8. So I'm going to subtract 8 from both sides. That's going to cancel out our 8 on the left-hand side, because 8 take away 8 is 0, and leave us with 3k equals -3, because 5 take away 8 is -3. Then the next thing we're going to do is we're going to say, okay, well, 3k means I have 3 being multiplied by k, and the inverse of multiplying by 3 would be to divide by 3 on both sides. And that would give me k equals -1. I'm going to skip down to example 3. And on example 3, same idea. So here's my variable. First thing I'd want to deal with is this plus 5. The opposite of adding 5 would be to subtract 5. And that would leave me with x over 2 equals 20. And then our variable is being divided by 2, and the opposite of dividing by 2 would be to multiply by 2. And again, whatever I do to one side of the equation, I got to do to the other. So I multiply by 2 on both sides, and that gives me x equals 40. So now what I'm going to ask you to do is we're going to go back and just check these. And you don't have to check it, say, every single time that you solve an equation. It's a good idea on a quiz or a test to just kind of do a quick mental check. But we're going to go back to 1, and we're going to say, well, how could I check to make sure that that's correct? And the way that I could do a quick check is through substitution. So if I'm saying that k equals -1, then I should be able to take my original equation, which is 3k plus 8 equals 5, and I should be able to substitute in -1 for k, and it should give me an equivalent equation. So meaning what's on the left-hand side is going to equal what's on the right-hand side, okay? And so order of operations here, I'd multiply first, and then adding together -3 and 8 gives me 5 equals 5. So that checks out, meaning I know that I have the right value for k because what's on one side of the equation is equal to what's on the other side of the equation, okay? And I could do the same thing here with 40. So I could check it real quick. Does x over 2 plus 5 equal 25? Does that work when I substitute 40 in for x? When I substitute 40 in, again, remember order of operations. So I'd want to divide first. 40 divided by 2 is 20. And 20 plus 5 is 25. Okay, so again, it's kind of like a way to prove to yourself that you did the work correctly. Okay, again, it's not like I don't need to check it, but it's not a bad idea to check our work. And also, especially if you're like doing a worksheet or a checkout or a quiz and you get an answer that seems a little off, one way to see if you are off is to go back and substitute that value in to your original equation. So now what I'm going to ask you to do is I'm going to ask you to try 2 and 4 on your own, and the video is going to stop and give you some time to do that, and then it'll reveal my answers so that you can check your work. Okay, so you can now see my work for problem 2 and problem 4, and you should just check it against your own work. You can pause the video if you want to kind of look over what I did. 4 is a little tricky because this is a negative fraction, so to undo that in my equation, instead of just multiplying by 3, I'm multiplying by negative 3 on both sides so that y becomes positive at the same time. Okay. Now let's move on to some new stuff, some things we haven't talked about yet. So one thing that we haven't talked about is equations like 5 through 8, where there's a fraction in front of our variable. And there's kind of a trick to deal with that in all one kind of foul swoop, instead of thinking about it as multiplying by 4 and dividing by 3, we can get rid of that fraction all at once. And so the way that we do that is using our reciprocal. A reciprocal means I am taking my fraction and I'm flipping the numerator and the denominator. And what happens with that, so I'm going to just write a fraction, 3/4. The reciprocal of 3/4 would be 4/3. And all I did there is I took the denominator and I moved it to the numerator, and the numerator now lives in the denominator. Okay, the little flip-flop there. And if I multiply a fraction by its reciprocal, well, if I multiplied here, it would give me 12 in the numerator, and it would give me 12 in the denominator, or it would give me 1. And so this is helpful when we're solving equations, because, for example, let's say I had 1/2 x minus 2 equals 1. Okay. So if I'm solving this equation, then I can add 2 to both sides first. I have 1/2 x equals 3. And then to get rid of this fraction in front of my variable, if I multiply by the reciprocal, and remember, whatever I do to one side, I have to do to the other. Okay, so if I'm going to multiply by the reciprocal of the fraction on the left-hand side, I got to multiply on the right-hand side as well. We already saw over here that multiplying by the reciprocal gives me 1. So multiplying 1/2 by 2 is going to give me 2/2, or just 1x. Now my x has been isolated. And then over here I have 3 times 2, and x equals 6. Okay, so we're going to look at a few examples here. On 5, first we need to add 2. Okay, we still need to deal with that addition subtraction stuff first. So I have 4/3 x equals 16. And then to undo this fraction, okay, I'm going to multiply by the reciprocal of 4/3, which would be 3/4. And whatever I do to one side, I need to do to the other. And that's where sometimes it gets a little tricky. We have to be really solid on multiplying by a fraction. Okay, so multiplying over here, and if you think about inverse operations, really the same thing's happening here. So like I'm multiplying by 4, so the inverse of that would be to divide by 4. I'm dividing by 3, so the inverse would be to multiply by 3. And what ends up happening is they cancel each other out, or give me just 1x equals. Now over here, this is why our fraction operations is super important. So I can either multiply straight across and then reduce, or remember we can cross reduce here. And notice I wrote 16 as 16/1, just so I can see numerator, denominator, numerator, denominator. So what I would probably do is reduce this to 4/1. And now I'm just going to multiply numerator and multiply denominator. And 4 times 3 gives me 12, and 1 times 1 is just 1. So I don't need to do anything else there. I don't need to write over 1. I can just write x equals 12. Okay, so there's one example. Let's look at another one together. On this one, here's my variable. I still want to start with this 5 though. So the inverse of +5 would be to subtract 5 from both sides. And that's going to give me -2/7 x equals 6. And then to undo this fraction, I want to multiply by the reciprocal, but I also want to get rid of the fact that it's negative. So to get rid of the fact that this is negative, I'll multiply by -7/2. So I want to make sure to keep my signs the same as well. And a negative times a negative is going to give me a positive 1 afterwards. And really careful to keep consistency, right? So if I multiply by -7/2 here, then I need to multiply by -7/2 on the other side, okay? And if I look at what would happen here, this would give me 14/14, or 1x equals, and then in terms of my fraction, times this whole number, 6, again, I would probably reduce. 6/2 is 3/1. And now I'm going to multiply numerators together, which would give me -21, and denominators together, which would just be over 1, and I don't need to write that. Okay, so now I'd like for you to try solving for our x on 7 and 8, and then the video will start back up again and allow you to check your answers. Okay, so now I want you to check your work on 7 and 8, and again, you could pause the video and look over what I did, looking to make sure you have correct signs in your final answer and that everything's reduced fully. So now we're going to move on to some equations that have a little bit more going on, so more than two-step equations. And so there's kind of a procedure that we want to follow when we're solving more than two-step equations or multi-step equations. And the first thing that we want to make sure that we do is we want to make sure that if there's any parentheses that we clear them first. So clear any parentheses. And what I mean by this is we're going to distribute if needed. Okay? So using the distributive property, we'll clear any parentheses. Then we want to combine any like terms. And when we're considering combining like terms, I don't mean like any x's anywhere can be mushed together, or any constant terms anywhere can be mushed together. Those like terms have to be on the same side of the equal sign. And that'll make more sense after we do a few examples. Okay. And then we want to, before we start to isolate a variable, we have to have that variable only in one spot. So the next thing we're going to do is we want to make sure that our variable is only on one side. So collect variable term to one side of the equation. Once we've done that, now we're solving. And so we solve by first adding or subtracting, and then multiply, divide. So once we get to the solve step, this is really what we had just been doing, where now we're at our two-step equation. So first we add and subtract things away, and then we multiply and divide things away. And it's all about, at this point, inverse operations. And it's all about inverse operations. So over this lesson and next lesson, we'll start to add in some of these steps, okay? So first, let's look at our example here about combining like terms. So if I go through these steps, there's no parentheses to clear. Step 2 is combine any like terms that are on the same side of the equal sign. So on this example, I have x's, I have 7x, and I have -3x, and they're on the same side of the equal sign. So first thing I want to do is I want to combine that so I have a single variable term to work with. So 7x take away 3x is going to give me 4x, subtract 8, equals 24. Then step 3 is collect the variable term to one side. We're good, right? We already only have x on one side of my equal sign. So now I'm doing what we were just doing and solving. So I'll add 8, and I'll get 4x equals 32, and I'll divide by 4 on both sides, and I'll get x equals 8. And again, just like on our beginning examples, I could go back, plug 8 into the original problem anywhere that I see an x, and make sure that it works. So let's go through these next two examples relatively quickly. So again, same idea. I have like terms on this left-hand side of my equation. I have 3x and 1x, or I have 4x altogether. 4x minus 7 equals 5. And now to isolate x, I'll add 7. And 4x equals 12. And divide by 4. And x equals 3. Now this next one kind of looks scary, but once I get started, you'll see some kind of magically gets really simple for us here. So again, I have like terms. Now if I combine these, this already has a common denominator. So if I have 8/3 x and I take away 2/3 x, that's going to leave me with 6/3 x plus 7 equals 13. Especially with fractions, but anytime we should really be looking for ways that we can write things cleaner, more simplified. And 6/3 would be silly to leave because 6/3 is the same as 2. So that's really 2x plus 7 equals 13. Okay, so right here, we're just simplifying or reducing. And now I'm at my variables on one side, so I'm good to go. I'm going to subtract 7. And that gives me 2x equals 6. And I divide by 2. And I get x equals 3 for my final answer. Okay. And it's really important to show all of these steps. You may be able to look at some of these equations right now and just be able to kind of problem solve through what the answer is. And I noticed some of that work while I was grading some of your papers. But I really want to see those steps, and it's a good practice for you to start writing these steps because you'll see these equations will get kind of progressively more involved. And having this procedure down now will make your life a lot easier 2 lessons from now, okay? So now let's kind of add a layer, right? So first step was clear parentheses. So now we're looking at an example where we have to actually go through the process of distributing and clearing parentheses before we begin with the solving process. So this 5x, not a part of the distributing, so I still have 5x. I'm distributing 3 to each term in my parentheses, so that's going to give me 3x plus, and 3 times 4 gives me 12, equals 28. So step 1, clear the parentheses. Step 2 that we wrote up above is combine like terms. So now that I've distributed, I can see that I have like terms here that I should combine. Altogether, I have 8x on this side of my equation. 8x plus 12 equals 28. My variables are to one side, so I'm good to go there. I'm going to subtract 12, which would give me 8x equals 16. And I'm going to divide by 8, which gives me x equals 2. Okay, so let's do another example together. Again, we're really careful with this distributive property, right? So this term's not a part of it. We also can't combine these together before starting. We're going to distribute the 12 through to each term in the parenthesis. I still have 4x, and distributing 12 would give us 12x. Subtract 36 equals 28. So another note here, just being really careful with our signs. So positive 12 times x is positive 12x. Positive 12 times negative 3 is negative 36, or subtract 36. Combining our like terms here, so I have 4x and 12x, and adding that together is going to give me 16x. And, minus 36 equals 28. And now I'm just set to solve. So I'm going to add 36 to both sides. And that's going to give me 16x equals 64. And dividing 64 by 16 is going to give me x equals 4. Okay. Let's look at number 2. This one's a little trickier because of the signs. So again, 2x still going to be there. I'm distributing the negative 5. So that's going to make this negative 5x. And then negative 5 times negative 9 is going to make this positive 45 equals 27. Okay, so just being really careful with our signs there. And then again, so I've cleared parentheses, step 1 done. Step 2, combine like terms. So I have like terms here, and again, being really careful with our signs. So that's going to give me negative 3x plus 45 equals 27. And now I'm going to have the 27, and I'm going to subtract 45 from both sides. So 27 subtract 45. Let's take a moment to think about that. It's going to give us negative 18. And then, again, careful with signs here. I'm dividing by negative 3. Negative divided by a negative is going to give me a positive 6. Again, as these get more involved, remember, we can always go back and check. So just to kind of show you how that check gets a little more involved, I never like I don't want to check here or here. I want to go back to the original equation, and I want to substitute in my variable there and make sure that it would work out. So here's my original equation. And if I'm saying x equals 6, then anywhere in my original equation that I see a 6, I'm going to substitute it in. Now what's different is when I'm checking, I'm really just doing order of operations. So in this case, I don't have anything to clean up on the right-hand side. So I'm just going to clean up the left-hand side, starting with parentheses, which 6 subtract 9 is going to give me negative 3. I'm just going to keep cleaning up. So now I'm going to do multiplication. This would give me 12. And negative times a negative is going to give me a positive 15. And then now adding together, 27 equals 27. Okay? So again, do we have to check every time? No. Is this my answer? No, this is my answer. I'm just kind of verifying for myself that if I took 6 and substituted it in, that it works out. And again, we're looking for that balance on both sides. So now the video is going to stop again and give you a chance to try 3 and 4 on your own, and then you can check your work in a minute. Okay, so check over your work here. 3 is a little bit easier than 4. 4 is more challenging because when we're distributing, we want to make sure that we're distributing the negative 3, giving us negative 9x, and positive 30. Negative times a negative makes this a positive. The other tricky thing with 4 was the first time that we saw like terms that weren't the variable terms. So 2 and 30, those are like terms, not variables, still can combine them. I also feel like when it's set up the way 4 is, students have a tendency to do this addition subtraction first. So just remember that that's a not okay thing to do. Okay, that's incorrect order of operations. So we have to deal with this multiplication here, or distributing, before we can combine this 2 with anything that it's a like term with it. Okay, so just don't be tempted to combine things that you can, oh, I know what 2 minus 3 is. That's going to kind of mess up everything down the road because it's going to give you the wrong term to distribute and the wrong answer in the end. Okay, so when it's set up like this, I feel like students tend to do the right thing. This sometimes gets you. Okay, so first we distribute, then we can collect like terms, and then we move from there. Okay, so one last thing we're going to talk about today, again, going back to that reciprocal that we talked about earlier. So similar to, let me go back to that first page, when I have a 2-step equation and I have just a fraction times this single term, if I have, and I don't honestly love these equations because I don't feel like we see them very often. Most of the time when there's fractions, it's more complicated than something like this. With something like this, I could distribute. The issue with distributing is it's going to create a fraction here and a fraction here because it doesn't distribute in nicely, meaning 6/5 and times 3 isn't going to clean up in any way or reduce to some pretty number. Because it's just a fraction times a single parenthesis, I can use reciprocal to make this a little bit cleaner on myself. If there had been anything else involved in this equation, if there had been a term here, a term added on this side of the parenthesis, we wouldn't be able to do that, okay? But as long as it's just a fraction times a single parenthesis equals a number, okay? So if I have some fraction, well, that's not the best color to use, A over B, times a certain parenthesis equals a single number, well then instead of distributing that fraction through, instead of that, I don't care what's in this parenthesis, if it's a single term or like, for example, at the beginning when it was just X, I was by the fraction, or if it's 2 terms or 3 terms in that parenthesis, it doesn't matter. As long as I have the fraction just times 1 something equals a number, then I can multiply by the reciprocal and get rid of that fraction. Okay, and it would just leave behind whatever was in that parentheses. So same idea if this was -6/5 just times X equals 66. Well, we know that we could multiply by the reciprocal. We did it on the first page, which would be -5/6. And that a fraction times its reciprocal gives me 1. This would give me 30 over 30, which is 1x equals, I'm cleaning this up here, so reducing, equals -55. Okay, so just as this would have worked early in our notes, same idea here. So I can multiply by the reciprocal and this particular equation, and that would again give me 30 over 30 or 1 out front and just leave me with the x plus 3. And I don't need the parentheses anymore because I don't need to distribute 1 through. 1's not going to change anything. 1 times x is x and 1 times 3 is 3. And we already did this cleaning up here where I reduced, made this 11 over 1. So that gave me -55. And then now just solving, okay, so unlike on this side, I still have to solve, so subtract 3 to solve, and it gives me x equals -58. So looking at another equation, and again, the only reason this is gonna work out for me is because it's just a fraction times a single something equals a value. And so to undo this fraction, the reciprocal of 4/3 is 3/4. So I'm going to multiply by 3/4 on both sides. And this would give me 12 over 12, or just 1. These 4's and those 3's cancel. And it's going to leave me with x minus 7 equals, cleaning this up, I can reduce -12 over 4 is going to be -3 over 1. And then multiplying numerators together gives me -9 over 1. Now remember, I still have to solve. So I'm adding 7 to both sides, and x equals -2. Now I want you to try number 2 on your own, and then check your work when you're done. Okay, so checking your work on this second example, we've multiplied by the reciprocal, which would get rid of our fraction and leave us with just the 2x plus 9. Okay, multiplying 10 by 7/5 gives us 14. And then subtracting 9 from both sides and dividing by 2 gives us 5/2 for our answer. Okay, so now you are going to have tomorrow, Thursday, you'll have some practice work involving the beginning of multi-step equations, okay? And then over the next few days, these videos will kind of add in additional things that we may see when we're solving equations and strategies to deal with those things. Tomorrow, I should be meeting with the A cohort group over Zoom, and we'll always be on Zoom from 8 to 8:40. Okay, so I'll see you all tomorrow.